It is very hard for archaeologists to explain how that was done.
That's why I'm more interested not in how the Egyptians built the pyramids, but how the pyramids helped to build Egypt.
Scientists once believed they had already solved one of ancient Egypt's greatest engineering mysteries, how the Egyptians carved massive blocks of granite. The accepted explanation was simple: copper tools, dolerite stone hammers, and the relentless labor of thousands of workers. Then researchers analyzed the famous Aswan granite quarry using Grok AI, expecting it to confirm the traditional theory. It didn't. Instead, the AI identified patterns in the tool marks that didn't match what historians expected. Its analysis suggested that many of the smooth, evenly spaced grooves were inconsistent with the irregular impact marks produced by handheld stone hammers. The conclusion stunned the researchers and reignited one of archaeology's biggest debates. What did the AI notice that everyone else had overlooked? Stay with me, because once you see it, it's almost impossible to unsee. Before we reveal what the AI discovered next, make sure to subscribe and turn on notifications so you never miss our latest ancient mysteries, hidden history, and unbelievable discoveries. The Aswan Granite Quarry. On the banks of the Nile in southern Egypt lies the Aswan Granite Quarry, one of the most important archaeological sites in the ancient world. At first glance, it appears unremarkable: unfinished stone blocks, weathered granite, an endless desert stretching into the distance. Most visitors walk through in just a few minutes, but the closer you examine the granite, the stranger it becomes. The mystery begins with the stone itself. Granite is an exceptionally hard rock, ranking about 7 on the Mohs hardness scale. Even today, cutting granite requires specialized equipment, diamond tools, and significant effort. Professional stoneworkers know how resistant it is, making every precise cut a challenging task. Now look closely at the marks carved into the quarry walls. Long, sweeping grooves curve across the granite with remarkably consistent spacing. In many places, the cuts appear smooth and continuous, flowing across the surface without sudden interruptions or random impacts. Rather than looking like thousands of individual hammer strikes, they resemble the path of a single tool moving steadily across the rock. That observation raises an unsettling question. Could these marks really have been made thousands of years ago using only handheld stone tools? For decades, archaeologists have answered yes. According to the traditional explanation, ancient Egyptian workers used extremely hard dolerite-pounding stones to gradually break away the granite. Tens of thousands of laborers worked in rotating shifts, striking the rock for hours every day over months or even years until enormous blocks were freed from the bedrock. On paper, the theory appears reasonable. With enough workers and enough time, even the hardest stone can eventually be shaped. But several researchers wanted to test the idea, rather than simply accept it. They recreated ancient dolerite hammers, selected skilled craftsmen, and attempted to reproduce the quarry marks using the same techniques described in archaeological literature. The results were unexpected. Instead of producing smooth, evenly spaced grooves, the repeated hammer blows created rough, irregular scars. Some strikes penetrated deeply, while others barely marked the surface. The spacing constantly changed, edges chipped unpredictably, and the granite fractured in ways that looked nothing like the patterns visible at Aswan. Perhaps the most revealing discovery was that increased effort didn't improve the results. As the workers became tired, their accuracy declined. Their swings varied, spacing drifted, and the surface became even more irregular, exactly what would be expected from human fatigue during repetitive manual labor. When those experimental marks were compared with the actual quarry surfaces, the difference was striking. The grooves at Aswan appear remarkably uniform, almost as if a single cutting tool traveled across the granite at a steady speed and constant pressure. Whether that appearance reflects a technique not yet fully understood, highly skilled craftsmanship, or another explanation entirely remains an active topic of debate. What is certain is that the quarry continues to challenge researchers and remind us that many details of ancient Egyptian stoneworking are still not completely understood. The more researchers examine the granite, the more one detail refused to fit the traditional explanation. The quarry walls are covered with long, sweeping, curved grooves that maintain remarkably consistent spacing from one cut to the next. At first glance, that may not seem unusual, but anyone who has worked with stone knows that level of uniformity is extraordinarily difficult to achieve by hand. Human beings have limits. No matter how skilled a craftsman may be, muscles tire, grip changes, striking angles drift, and every swing becomes slightly different from the last. That natural variation is part of human movement. Yet across many of the marks at Aswan, that expected inconsistency appears to be surprisingly small. This was the point where some researchers decided to approach the mystery differently. Rather than relying entirely on traditional interpretations, they created detailed, three-dimensional digital models of the quarry using thousands of overlapping high-resolution photographs through a technique known as photogrammetry. Every groove, ridge, and surface could then be measured with remarkable precision. The digital models were analyzed using an artificial intelligence system, trained to compare cutting patterns with thousands of different tool signatures. The software was designed to measure geometry rather than archaeological theories. It evaluated the curvature of each groove, entry angles, cutting depth, spacing between neighboring marks, and overall consistency across the quarry surface. According to this account, the system analyzed 847 individual cuts. After processing the data, one figure attracted immediate attention. The measured variation between many of the cuts was reported to be only 4.3%. Whether that exact value is accurate remains open to verification, but if correct, it would represent an unusually high level of consistency. Modern hand craftsmanship often shows much greater variation, because even experienced workers cannot reproduce identical movements indefinitely. Fatigue, posture, and countless small factors naturally influence every strike. If the reported measurements are correct, the grooves appear far more uniform than many researchers expected. That raised an important engineering question. If the marks were not produced entirely by repetitive handheld pounding, what process created them? The AI then compared the quarry marks with thousands of known cutting patterns from both ancient and modern tools. The traditional pounding stone model ranked poorly because repeated hammer blows generally create irregular impact scars, inconsistent depths, and constantly changing strike angles. Those characteristics did not closely resemble many of the measured grooves. Instead, the closest pattern matches reportedly came from three categories of modern stone-cutting technology. The first resembled diamond rotary cutting, where rapidly spinning diamond-tipped tools create smooth, continuous grooves through extremely hard stone. The second showed similarities to abrasive water jet cutting, which uses high-pressure water mixed with abrasive particles to carve remarkably controlled cuts. The third resembled ultrasonic machining, a process in which high-frequency vibrations allow tools to remove material with exceptional precision. These comparisons do not mean ancient Egyptians possessed modern machinery. They simply indicate that, Based on geometric pattern matching alone, some of the quarry marks resemble cuts produced by highly controlled mechanical processes more closely than irregular hammer impacts. Whether that similarity reflects unknown ancient techniques, exceptionally skilled craftsmanship, limitations in current experimental reconstructions, or another explanation altogether, remains an active subject of debate. What everyone agrees on is this: the granite walls of Aswan continue to challenge researchers, and the precise methods used to shape some of Egypt's hardest stone are still not completely understood. Then the evidence became even harder to ignore. Researchers examined the granite surfaces using high-powered microscopes, expecting to find the familiar damage left behind by repeated hammer blows. Instead, they found something completely different. When a heavy stone hammer repeatedly strikes granite, it creates microscopic fractures. Tiny mineral crystals shatter in random directions. Stress lines spread beneath the surface, and the edges become chipped and irregular. This type of damage is unavoidable because every impact sends shockwaves through the rock. But the granite at Aswan did not display those characteristics. Under magnification, the cut surfaces appeared remarkably clean. Instead of shattered crystals and deep impact fractures, researchers observed what engineers describe as a shear surface, a smooth separation where the material appeared to have been sliced away rather than smashed apart. Even more surprising was what lay beneath the cuts. If thousands of hammer blows had created these grooves, the damage should have extended several millimeters into the granite. Instead, the underlying stone remained almost completely undisturbed. The force seemed concentrated only along the cutting path, as though whatever removed the material did so with extraordinary precision instead of brute force. Then came another unexpected discovery. Across multiple samples taken from different areas of the quarry, scientists identified extremely fine spiral striations, microscopic circular patterns that all rotated in the same direction. These marks resembled the signature left behind by a continuously rotating cutting tool rather than repeated impacts from handheld hammers. The consistency was remarkable. Whether the sample came from one section of the quarry or another hundreds of feet away, the microscopic spiral patterns matched with astonishing accuracy. It looked less like the work of countless individual laborers and more like the output of a single controlled process, repeated over and over again. Researchers also detected localized thermal alteration. Small areas along the cut surfaces showed evidence that temperatures had briefly risen far above the surrounding stone. The heat was tightly concentrated instead of spreading through the granite, exactly the kind of thermal signature engineers associate with high-speed rotary friction. That observation created another problem for the traditional explanation. Hammering granite generates impact damage, but very little concentrated heat. Repeated pounding simply breaks the stone apart. It does not produce narrow zones of localized heating confined to the cutting edge. Rotating industrial tools, however, routinely create precisely this type of microscopic thermal pattern. The faster a cutting head spins against granite, the greater the friction generated directly at the point of contact. Modern diamond saws, rotary grinders, and precision machining systems all leave similar signatures. No one is claiming ancient Egypt possessed modern industrial machinery, but the microscopic evidence was now pointing in the same direction as the surface analysis, the spacing measurements, and the AI comparison. Every new layer of investigation seemed to move farther away from the traditional hammer and stone explanation. For many researchers, this became the central mystery of Aswan. If simple pounding tools created these marks, why do they fail to reproduce them experimentally? Why is the microscopic damage inconsistent with repeated impacts? Why do the spiral patterns resemble rotary motion? And why do the thermal signatures appear concentrated exactly where modern cutting systems generate friction? These questions remain the subject of ongoing debate. Some archaeologists argue that combinations of stone hammers, copper tools, abrasive sand, and extraordinary craftsmanship could still account for the evidence. Others believe the quarry preserves indications of stoneworking techniques that have yet to be fully understood. Whatever the final answer may be, the granite itself continues to challenge assumptions. Because unlike theories written in books, the stone has never changed. It has remained in the desert for thousands of years, preserving every groove, every microscopic mark, and every unanswered question for anyone willing to look closely enough. Then came perhaps the most controversial evidence of all. Researchers examined tiny particles trapped inside the ancient tool marks. Among them were microscopic grains of corundum, one of the hardest naturally occurring minerals on Earth. Ranking 9 on the Mohs hardness scale, corundum is widely used today as an industrial abrasive for grinding wheels, polishing compounds, and cutting discs because it can wear away materials that ordinary steel cannot. In several samples, investigators also reported carbon-rich structures that some described as having a diamond-like crystalline form. Individually, none of these findings would be enough to rewrite history. Corundum occurs naturally, and carbon can appear in different geological forms. But when these observations were considered alongside the remarkably uniform tool marks, the microscopic spiral striations, the localized heat signatures, and the absence of deep impact fractures, they appeared to describe something very different from repeated hammer blows. When Grok AI analyzed all of these characteristics together, it reached a conclusion that surprised many researchers. According to its pattern analysis, the closest modern manufacturing process matching the complete collection of evidence was industrial-grade rotary abrasive cutting, similar in principle to high-speed diamond cutting systems. The machine found very little similarity with Bronze Age percussion tools or traditional stone hammers. Under the microscope, the granite did not appear to have been smashed into shape. It appeared to have been machined. Then the mystery took an even stranger turn. Researchers studying the quarry noticed traces of ancient red ochre paintings applied directly over several finished cut surfaces. The sequence was unmistakable. First, the granite had been cut. Only afterward had someone painted on top of it. If those paintings are accurately dated, some researchers argue they may predate Egypt's early dynastic period by thousands of years. If true, the tool marks beneath them would have to be even older. That possibility led the AI to perform what it called a temporal precision analysis, comparing the estimated ages of different cutting surfaces with the quality of their workmanship. If the work was progressing so precisely, why was it suddenly abandoned? The unfinished obelisk, which would have weighed more than 1,000 tons, still lies attached to the bedrock at Aswan. The traditional explanation is simple. A large crack formed, making the stone unusable. But researchers notice something unusual. Tool marks continue beyond the crack, suggesting work may have continued even after the fracture appeared. Even more intriguing, the obelisk displays the same smooth curved grooves, consistent spacing, and precise machining-like marks found throughout the Aswan quarry. The quality never seems to decline, even in tight areas where using large hand tools would have been extremely difficult. The mystery doesn't end at Aswan. Similar granite cutting patterns have been identified at sites around Egypt, including the Valley Temple of Khafre near Giza. According to AI comparisons, the variation between these tool marks is less than 5%, suggesting an astonishing level of consistency across different locations. If accurate, this raises an important question. Was there once a standardized stoneworking technique that later disappeared from history? Supporters argue this could point to a lost technology or forgotten engineering method. Mainstream archaeologists, however, maintain that highly skilled craftsmen using known ancient techniques can explain the evidence, although the exact methods remain debated. Whatever the answer, the granite continues to challenge researchers. The marks are still there, the precision is still measurable, and the debate remains far from settled. So what do you think? Was this the work of extraordinary ancient craftsmanship, a lost technology, or is there another explanation we haven't discovered yet? Share your thoughts in the comments, and if you're fascinated by ancient mysteries and discoveries that challenge history, don't forget to subscribe and turn on notifications for more videos. It bears the same distinctive curved grooves, the same remarkably uniform tool marks, and the same unanswered questions that appear throughout the rest of the quarry. Whatever created those marks, it left its signature everywhere. If the work was progressing so precisely, why was it suddenly abandoned? The unfinished obelisk, which would have weighed more than 1,000 tons, still lies attached to the bedrock at Aswan. The traditional explanation is simple: a large crack formed, making the stone unusable. But researchers notice something unusual. Tool marks continue beyond the crack, suggesting work may have continued even after the fracture appeared. Even more intriguing, the obelisk displays the same smooth curved grooves, consistent spacing, and precise machining-like marks found throughout the Aswan quarry. The quality never seems to decline, even in tight areas where using large hand tools would have been extremely difficult. The mystery doesn't end at Aswan. Similar granite cutting patterns have been identified at sites around Egypt, including the Valley Temple of Khafra, near Giza. According to AI comparisons, the variation between these tool marks is less than 5%, suggesting an astonishing level of consistency across different locations. If accurate, this raises an important question. Was there once a standardized stoneworking technique that later disappeared from history? Supporters argue this could point to a lost technology or forgotten engineering method. Mainstream archaeologists, however, maintain that highly skilled craftsmen using known ancient techniques can explain the evidence, although the exact methods remain debated. Whatever the answer, the granite continues to challenge researchers. The marks are still there, the precision is still measurable, and the debate remains far from settled. So what do you think? Was this the work of extraordinary ancient craftsmanship, a lost technology, or is there another explanation we haven't discovered yet? Share your thoughts in the comments, and if you're fascinated by ancient mysteries and discoveries that challenge history, don't forget to subscribe and turn on notifications for more videos.